In the last video, we started talking about object-oriented programming and classes. Let's continue with that in this video. Okay, moving forward, let's create our method. And what we want to do is allow the method to update the model. So how do we do that? Well, we start by typing public. And again, that's the access modifier. So what we're doing is we're saying we want to make this method that I'm about to create publicly accessible, much as we've done the same with the class. So we're going to put public void because it's not going to return any data. We're going to call it set model. Now notice how I started typing, IntelliJ came up automatically and said, oh, do you mean set? And it's got automatically created a start of a method for all 5 of our variables, our fields in this class. I can come down here and just press model and press enter over set model to say that's the one I want. Then we're going to introduce a parameter. And the parameter we want is going to be a string because we want the other class to send the string that they want to be created and for it to be updated in here. So we're going to call that string model. And that introduces another problem. Now the problem here is we've got 2 different types of variables. If you think about it, we've got the field that we've defined up here called model, but we've also got another one in here called model. Now obviously this one here is a parameter that's been passed to this method, and this first one up here is a field. So how do we distinguish between the two? Because as far as IntelliJ or Java is concerned, we need to be specific to say which one we want to update. What we want to do here is we want to actually update this field with the contents of the parameter that was passed to us and update it in here. So how do we do that? Well, it turns out there's a way to do that. And the way to do it is you type the word this when you're referring to the field for the class. So in other words, if we want to update or access this particular field, we put this, the keyword this, before the definition. So we type this dot, and notice when I type model, it automatically comes up for us from IntelliJ. Press enter, equals, and then if you type model, you notice here to the left, IntelliJ is showing you the little p, which stands for parameter. So it's saying now this is going to be the model. Because we haven't specified this dot for the second component, IntelliJ is going to default to that for us automatically, like so. So what that's done now, it said update this variable here with the contents of the parameter model that was passed to us. So that's a way of updating the model using a method instead of trying to access it directly. So just to show you how that would work, if we go back to our main class again, you notice we're getting an error here now, and that's because I changed the definition, which was the access modifier, which was public, back to private again. So it's saying it can't access it. So if we actually want to update that model, the better way of doing it, we put Porsche dot, and notice how set models come up, set model. And what we do, we pass a parameter, is seen parameters passed with methods before, like so. And that is a way of then calling the set model method for our object and updating it with the value Carrera. Now if we run that, it'll seem to work, but we won't get any output. And of course the reason we won't get any output is because we haven't anywhere outputted anything. So we just got a message to say that it completed with execode 0. The other thing I want to show is what happens if we don't do this, cut this first line here, the new car. So if I comment that first bit out there, so we've just got a variable like so, comment that out. So we've just defined the variable, we haven't initialized that, we haven't put equals new car. Already this is IntelliJ saying variable Porsche may not have been initialized. So it's sort of saying there could be a problem there. Because unlike data types, there isn't default values with classes. You have to initialize them using the new keyword. Now if I don't do that, this is what happens. We get an error to say that it may not have been initialized properly. So that's a compile error, but also if we don't initialize it, we can actually get it to crash. So for example, if I undo that change, this is like more or less forcing it to crash. I sort of trick IntelliJ now and run it. We actually get an exception, which you can't see too much there, but it's basically get an error, null pointer exception. And what that essentially means is you've defined a type called Porsche, but it hasn't been initialized. So in other words, we haven't created an object from the template, which of course is the class. So that's where you need to make sure the new is always executed. And again, I sort of more or less just fudged this to actually cause that error to come up anyway. The bottom line is I'm trying to say here is that make sure when you're creating classes, you always have to use this new, the keyword new, and then pass the name of the class, and then the brackets, you need to initialize it with the new keyword as I've shown there. So run that again to see what it does. It now works, but of course it's still not doing anything. So let's go back and add the ability for us to print something out. So I can go back to our car class. And let's create a getter. So we've created what's called a setter. And again, these are standard methods, but it's just the word set, and you see they're about to use the word get. These are known as setters and getters in Java. So I'm going to create a getter now called public string. We want to return the type. I want to return the type get model this time. Then we return this dot model, like so. And just to be clear there, when I type that, this dot model, you notice the little F by IntelliJ is saying this is a field, just so you know. So if ever you're unsure of the type of variable or the type of anything you see on the screen here, IntelliJ is really quite smart at showing you. So F in that case for field, M for method, so on and so forth. And there's also other things here. The little padlock is telling you that is a private method because the padlock is on. But in the case of method, the padlock is open, which is saying this is a public method which is accessible to other classes. So you'll get to know these various graphics in IntelliJ, which are really there to help you at a glance see what a particular variable or method is set as. So in this case, we want to return model. So I'm going to do like so. And we've now got a method that can be called elsewhere to return what the current model is. So we can go back to our main Java. And if we now do a system output, and we'll put model is plus, and we can type Porsche dot. Notice how there's two now. There's get, and there's also set. So we go up to get now. Get model is the method we just created. So now if we run that, model is Carrera. And just to show you what happens there, let's try also putting a print before we've actually set the model. So obviously this line here, this first line, is executed before we've actually set the model to Carrera. So let's see what happens when we do that. You can see it says model is null. Now null is the internal default state for a class and also for a string. And if you recall, if we go back to our car.java, string is actually a class. So string is a class. It's actually a special class, and we'll be talking more about string and how it sort of bends the rules, and it doesn't need to be created in the same way that we're creating this car. So it's early days yet, but you can see the functionality of Java is allowing us effectively, because string is a class, we can have a class within a class, if that makes sense. So the model, engine, and color are all classes in their own right because they're of type string, and they're stored in a class of the name car. So you can see that how this concept of a user-defined data type is coming back, because we've introduced really a super data type of type car that has got 5 fields: doors, wheels, model, engine, and color, but we've also assigned some methods to it as well. So both the state and the behavior are part of the class. Very, very powerful, as you can see. So let's talk about the concept of why would we want to use getters and setters. So we'll get rid of that first line because we don't need it anymore. But why are we doing the set model? What is the advantage to that? Well, what that means, by using the .set model, what we could do is, for example, we could go back to our car.java and we could have a look in this set model method, our setter, and we could do some validation. So what we could do is we could put string valid model equals model dot to lowercase. So we're going to convert whatever was passed to us to lowercase for starters. Then let's introduce a test to make sure that the only values we're going to accept from this class for this method are going to be a type Porsche and Holden. So what we could do in here, we could put if valid model dot equals. Now dot equals like this is a way to test that a particular value of string is equal to another type. So we can, by typing the valid model, which is again of type string, dot equals, and typing in what we want to search it against in brackets, we can actually test that, and that will return true or false if they're equal. So what we're saying is if the model equals a Porsche, And then we can put the OR operator, or valid model dot equals Holden. If that's the case, then what we can do is we can assign that value. So only if what was passed to us equals a Porsche or a Holden will we allow our internal state, our internal model field, to be assigned the value that's been passed to us. And that might be because we've actually got a rule when we're creating our class to only define those two types. So we can maybe want to put something like else this dot model equals unknown. So note also that I'm putting this dot model equals model. So I'm still saving what was passed to us, but I'm actually testing it. When I'm testing it in lowercase, so we're testing for all scenarios, but we're actually testing the lowercase version. So we've now got that set up. So if we go back here to our main Java again and have a look, and actually I think I got that wrong. I'll change that to, it won't be Porsche because it's the type. We'll say it's a Carrera instead of Porsche because that was the name of the car, and we'll put Commodore, which is a type of Holden car. So we're now actually testing the model to see whether it's Carrera or Commodore. Sorry about that. So we go back here now and do a test. Now at the moment we're passing Carrera, which should be a valid one. So if we run that, model is Carrera. So that accepted it. The fact that we're actually displaying that the model is Carrera, if you have a look at our code again, we're only saving it to this dot model if it's a valid Carrera or Commodore. Otherwise, we're setting it to unknown, and then this is then printing that out with the get model getter. So if we actually change that, say to a 911, which is another type of Porsche, we run that, we get model is unknown, and that's because in our validation, in our set model method, which is our setter, we're actually explicitly only allowing Carreras and Commodores to be valid models that are created for this object. So you can see how it's very useful to have this type of functionality, the validation, not done at this point, but done within the car object itself via the methods that we're setting up in our class. So it means when you're creating a class, what you're doing is you can set up all the rules relating to that class, what is valid, what is not valid, and have it all set up, all that functionality set up within the car class itself, so that is inherited when we create the object. What that means is the code that is creating objects can't make invalid objects, so to speak. In other words, it can't create, in this case, for example, it can't assign a model number that we haven't defined as being valid in our car class. So that's the reason. So that's really the whole concept of encapsulation, is that by not allowing people to access the field directly, and by forcing them in this case to assign the model using a method, we can really make sure that the data within our objects are more valid and have been validated and are correct. So that's enough now about the basics of classes. In the next video, what we're going to do is we're going to start talking about constructors, which is this component here. So when we actually issued that command new car, it actually used a constructor to create the car object. So we're going to talk about constructors, what they are, and how to create our own constructors in the next video.